Okay, welcome to TLS at IETF113 here in Vienna and virtually online. Just a reminder for everybody, people who are online, blue sheets will be, attendance will be automatically collected. For those in the room, please scan the barcodes or the QR codes throughout the room to join the Meetecho mobile app so you can have your attendance counted and participate in polls and other important meeting things. You should all be familiar with the note well at this point, but here it is. Also, want to remind everybody of an IETF code of conduct to treat your colleagues with respect, try to be understandable and reasoned, using good judgment. That can be tough. And we're trying to find good solutions for the whole internet. All right, we have minute takers. Please also, I think usually people are on Jabber at this point, but if there's things that need to be relayed to the mic and we're not getting to them, please let us know. All right, we have some administrivia to deal with. That I think we're done with that. There are some working group drafts that we have in progress. So we'll discuss those at the meeting today. I think we have a request from Ben to discuss a kitten issue that we will add after the working group drafts, and then we'll have some discussion of new work. Are there any other agenda bashing topics that people would like to discuss? Sean, did you want to give any document update?
Yeah, hi, Joe, thanks. I just want to say thanks to the working group and all that's participated. We got 2 RFCs published since the last time. We met the TLS CID draft and the deprecate MD5 and SHA-1 draft. Yay! We have 3 documents with the RFC editor today. It's possible that DTLS 1.3 will pop out and ticket requests as well. We have the external PSK guidance document is out the door. And I guess there's another document that went back on the ISG telechat because it's been sitting around for a while and lost enough ADs to go forward. And it's only got a couple of minor editorial things that need to get fixed. So hopefully that'll pop through. So we're hoping that a lot of the logjam of the drafts that are in the working group will pop through. And as you can see that some of the notes in the asterisks in pink and yellow there on the left, on the bottom of the left-hand side column, they've been kind of sitting around for a while. So we're happy to move those on and get them out the door. And that's it, Joe. I think back to you, unless anyone has any specific questions about a draft.
I got logged out of the Meetecho. I think it should be back now. Okay.
Yeah, we see now. Can you go back to the slide real quick just to jog my memory here? Yeah, and the other thing is that delegator credentials is in IETF last call. And I guess we should note too that we paused 2 drafts, the cross SNI resumption and the flags extensions, until we actually get some implementation experience. And that's it. Back to you, Joe.
Okay. I think now we will start into our regularly scheduled program with, I think CTLS was first. Ecker, do you want to run slides? Or do you want me to? Is Ecker on the call? Oh, there you are.
Slide. I can run slides. I'll probably foolishly say, next slide about 8 times. Trying to remember, where's the button again?
On the, it's the thing that looks like a piece of paper on the upper.
Yes, under your name, to the right, to the left, I think, of the.
Yes, right. What could be more clear? Okay, I pressed the button, but it didn't tell me. Okay, there.
I
Wow,
just
that was
granted it, yeah.
not fast. Okay. Yeah, this is like really warm up for 8046 bits, so we can do this first. TLDR, I think we're getting pretty close to being done with this. Our intention was to take it to experimental, I think, and get some experience rather than try to take it to PS. I think I mentioned this last time. So recent changes, these are mostly due to comments by Ben Schwartz. So thank you, Ben. So I can just summarize these. The first is allowing optional elements in the profile. So you can have, if you have elements which are distinguishable by the receiver, whether they're or not, then you can have they have optional. Moving the profile ID to the client hello to make the structure clearer. Instead of having a conditional sequence number, which is conditional on the profile, making it conditional while you're doing stream or datagram. This seems to make more sense because you really need the sequence number if you're in the datagram. You don't need it if you're in stream. Some clarifications around the alerts and around the encryption computation. These actually don't change anything. They're just like, well, the encryption computation really doesn't change anything, and the alerts, I always intended the alerts to be the same, and somehow I just never wrote that down. So I don't know if you want to call it a clarification or not. That's sort of up to you. There's still a small number of issues. The next two are actually related, so I'm going to do them both, and then we can talk about them. We removed the length field to save some space, and the underlying idea was either that the messages actually, every message actually was self-describing, so you could parse the messages and then just stop. And also that perhaps this would be carried over transport that wasn't really like TCP, but was more message oriented, in which case you would need to do that because you could just like parse the end of the message. But if you're getting over TCP, this is actually kind of a pain because you have to actually parse through the message before you get to the end, rather than just being as an ordinary TLS. So you could just like look at the message header and find out how long it is, and then of course you're faced with the possibility that the message is not as long or short as it says it is, but at least you could have a 2-layer parser. So Ben suggested a flag in the record for this, but this of course won't work for UDP. And there's a separate issue, issue 41. Is Ben here, by the way? Let me just look. Good, awesome. About fragmentation for UDP. So we originally assumed that CTLS was going to run over TCP, and so we wouldn't need to reconstruct. And so the headers don't contain any of the information at all about how to read the reconstruction. So that's pretty clearly an omission. And then we just like said, well, this will work fine for DTLS. We like, we put a D in front of everything. And so that's not also fantastic. This is what happens when you have an implementation that only runs on TLS. My proposed solution to this, which I think people will be too surprised to hear, is to profile even further, which is simply have the traditional framing for both either have a version that has no framing, a version that has a length framing, and a version that has the full framing, and those would simply be as they are in the current system. Although we might make the integers a little smaller. I don't love this, but I think it's probably the most clean solution. And if it turns out it doesn't work, then as I say, the profile mechanism lets us save ourselves. So I guess I'll take comments, but this is my put on this. Ben, I figure you're gonna want to say something, maybe not.
Yeah, go ahead, Ben.
Hey. Cool. So what's the difference between length and full?
Length means TLS and full means DTLS, effectively.
Okay. So full is the one that supports
includes the fragment, length, whatever the fragmentation pieces. Yeah.
Okay. And just is this
happy to
optional?
write you the names,
and this is optional because it's because there are some use cases where you know that your handshake messages are so small that they fit into a single message?
I was more thinking a single record. No, I was more thinking use cases where you have a transport that's carrying them that somehow limits them.
Okay, so it sounds like you imagine that in the CTLS DTLS, we need a better CTLS UDP case that we would always use full.
I think she'd have to, yes.
Okay, and then the question is just on the CTLS TCP side, this would be an option for.
Well, I think that yes.
And the purpose of that option would be to save 3 bytes.
Affirmative.
Okay.
Yeah. I think, but no, I want to just like sharpen that a tiny bit, which is to say that there's a, one of the purposes of this exercise, though I think it may not be as clear as it was before we started, is also to like draw a clearer line between TLS and uses like a handshake protocol, but then with an exterior as an exterior AIK for other protocols, like it's used in Quick. And in that case, you might imagine having a protocol which had like full message framing, in which case you wouldn't have to worry about the problem of any framing at all.
Okay. Well, yeah, I don't have an objection to this.
Okay.
I'm not entirely sure I get the motivation, but it works for me.
Okay, I think I'm happy to like have, this is like obviously not like the most amazing thing ever, so like I'm really happy to like hear this is a bad idea in the future. I don't think no one says anything now. They're not committing themselves forever. Martin.
So when you say full, I'm looking at the TLS spec here, and it has a length, which is the length of the handshake message. There's a fragment offset and fragment length. Do we need all 3, or can we get by with just 2?
You can get by. You can get by. You can shave off 1 with a. You can. Sorry. You need all 3 with a. Sorry. If the semantics they currently have, you need all 3. But you can imagine different semantics which only had 2. In particular, if you had an end of message bit like IP does, you could shave off. You could take 1. You could rob. You could rob 1 bit from one of those, and then say there's only 2.
So that suggests there's maybe something we could do that's a little more efficient than just.
I think the DTLS one is pretty arguable. You can improve it, and I think actually arguably for TLS, you could just make it 2 bytes too. I think
almost certainly. Yep.
Okay. So I think I'm gonna put something like vaguely like this in here, and then people can like set that PR a little bit. Thanks. As I was hoping just to get a sense of how people thought we should proceed, because I hadn't like actually engaged with this as carefully as I was hoping. There are 2 other optimizations of the AIK which people suggested. One is omitting the random values in favor of requiring Diffie-Hellman to be random, and the other is omitting the finish value. So the implication of omitting the random is like you have to have some other source of randomness, which is obviously a problem if you do like pure PSK key exchange no Diffie-Hellman, which is like inadvisable in general. But also like a lot of the analysis people do often will assume the random values are there. The finished basically, as people recall from the discussion of TLS 1.3 when we first did it, if you take the finished out, you still do get integrity for the handshake, but you're relying entirely on the AAD on the subsequent messages. So it's not impossible, but like it substantially changes the analysis and the guarantees and the separation between those 2 proofs. I guess I think when we first started this, there was like an attempt to like radically sum that everything we possibly could, because there was a feeling like was the only chance we had. I think that my sense now is, now that we've got the profiling mechanism, these are things we could like just add later and don't have to do it now. And I'm sort of like, I think I'd rather try to get some. And the people I've talked to that actually are talking about doing this, like I think, let's say if we actually get any interest anyway. or rather, let's see if we get enough deployment justified, just and in cases that really have that narrow requirement to send out active pieces. Richard?
Yeah, I was just going to second that on the can we do it later. The profiling mechanism made this possible to do very, very cleanly in the implementation work I did. So I think this, as long as we believe the profiling thing can be extended, I think this is fine to do later.
Okay. I plan to do that, as I say. Okay. The second piece that I heard suggested, these are by the way, these suggestions are been floating around, but most recently are due to Karthik Bhargavan. So I want to make sure I'm giving proper credit there. Was to remove the transcript reconstruction piece. So Richard had this very clever idea of like treating this like a compression layer in the system. And then, but the implication of the compression layer is that then when you you actually operate at the TLS layer as if it were regular TLS, and then you like shrunk everything down and brought it back up again. So you had actually a compatible transcript, except for like some handshake value distinguishing that you actually were doing CTLS. This seems to add some like conceptual complexity and technical complexity, though I think there's some debate at how much. So I don't know if you want to think how we'll have thoughts on that or not. I'm the fence myself.
Hannes is at the mic line. Hannes, just
oh, fantastic! I couldn't see Hannes.
You can check in at the using the app too, but you don't have
Sorry
to do
about that, Hannes. I was looking on the actual queue, so I couldn't see you with the mic. Okay. You're very tiny.
No problem. Yeah, I'm far away.
Exactly.
So those three proposals were made by Karthik, as you said, and I think they are very good optimizations. But there's a kind of a chicken and egg problem. Before we didn't incorporate them into the document, so neither Karthik nor others like really sort of what it looked like considered them as a serious area of investigation, and so like delaying them to a later stage, I think could be tricky in practice because you don't want to do these sort of like bigger changes later on. Specifically, the transcript sort of reconstruction, because that could be quite a time saver implementation-wise, because now what I have to do is I have to basically construct the message and then rerun the whole process to create the kind of real message to just have the transcript version, which is in an embedded implementation not a piece of cake. In Richard's Go implementation, it's not a problem, but if you care about saving RAM and also the computational efforts, it is something. So I don't.
So much better.
Who to look for to actually do that analysis, because this is a pretty serious security analysis that needs to be done here. But it's not just oh, looks good. Sort of like
agreed.
back on the envelope assessment.
So I think this one we should resolve one with the other before we do this, because like I think that I think you're right. This is like the other things you can imagine adding later, but this one I think either we should do it if it should happen or not. I guess like to hear from other people. I'm sort of like, I thought this was a clever idea. I think when Richard first suggested it, but I've cooled on it some. So for the reasons you indicate, Hannes. So I guess I'll hear some other points of view. Maybe from Richard. Or maybe not from Richard. There you go.
I don't have a whole lot of stake in this fight. I think the transcript reconstruction stuff was mainly about kind of establishing logical equivalence between the compressed transcript and the real thing. In kind of an information theoretic point of view.
Right.
I don't think I ever envisioned the mechanical expansion, compression and extraction was necessary. So I think it would be useful to have, validation on this, but I expect the result of that, analysis would be that it's okay not to do the reconstruction.
Okay. Thanks. I think I know what to do now. I don't think That's all. Those are all the slides I have. So I'm unaware of any other proposed like changes here. I did go through the issues. Okay, sorry, I thought someone was going to the mic. I did go through the issues. So I think now that TTLS is basically done, I'm trying to clear out my queue of these other documents. As you can see, so my hope was to make these changes such as they are, and then ask for a working process call experimental.
Okay, sounds good.
I think I'm ready for 8446.
All
Although I
right.
think they called it 8846, which just to show, Okay, I have to do it. Do I have to like unshare and then share again?
I think so. I think you do.
Okay.
And I might have to check. There we go.
Here we go. Okay, I did call it the right thing. Look at that. Oh, I'm glad to see that my confusion about the number of the RFC is it only occurs at 2 in the morning. It does not generally occur. Okay. So this also is hopefully close to done. There are still a few substantive issues, some of which I propose to do something about, and some of which I propose to do little about. As people recall, the purpose of this exercise was largely to remove some problematic language from the document, and in the process to clean up some points that have been confusing in the RFC. It was not to make any substantive changes that would cause real problems or interoperability problems, because we're not planning to rev the protocol number. So so I think any change we make has to be measured against that question of, are we improving the world, or are we just digging ourselves a hole? And we do have sort of an overhang of obvious confusion about different pieces, as well as the problematic language. So I do want to get this out, and if there are things that are grievously wrong but require a lot of engineering time, I want to kind of punt them, or even less grievously wrong, hopefully. I guess if they're grievously wrong, we have to fix them. But if they're just complicated and somewhat confusing, but edge cases, maybe less important, since we already have 8446. First issue was by John Mattson, who I don't know if he's actually here, because I know he's presenting in some other meetings, so I don't see him here. Was to have recommendations around ECDHE. Currently, key update offers PFS because you hash keys forward, route keys forward. So as long as you delete the old keys, you're fine, which always is a condition for PFS. But it doesn't offer PCS, and for that, of course, you need a new ECDHE exchange. So John proposed, we did add some text explaining this point, but in that PR, John proposed also recommending a new exchange at some specific intervals, namely an hour or 100 gigabytes. Those seemed a little ad hoc to me, and it seemed like we probably did not need that. So my proposal actually is to close this with no change, which is what I marked on the bug. Obviously, if people, I said since John is not here, if John wants to reject it in the PR later, that's okay, or in the bug. But I wanted to see what other people thought, if anybody else believed we should make this change, and if so, we could discuss it. Hearing no objection. The second, this is also John Mattson. TLS has a relatively rich set of errors for certificate problems. So there's certificate revoked, certificate expired, certificate unknown. Doesn't really have anything for PSKs. PSKs, after all, were kind of an afterthought in the original TLS, and 1.3, we didn't bother to extend the alert set. So PR 1251 suggested repurposing these alerts to mean the same, effectively mean the same thing about the tickets. That seems confusing to me, since after all, you could have a PSK and a ticket simultaneously. A PSK and a certificate, although I guess it would go in the opposite direction, depending on the time of the handshake. My sense is that these granular messages in ordinary TLS for the certificates were not actually as helpful as you might have seemed. And in particular, because of the way, because of the way the path construction happens, you could, especially for intermediates, you might encounter any of these. For the same certificate. So my sense is probably that's not a great idea. And I think we should just, if we're going to do anything, we should add just a ticket invalid alert that says like something's wrong with your ticket. It's also the case that depending on exactly your service constructed, you might or might not encounter this forgiven ticket because it's possible to have like a to fall back to ordinary certificate-based authentication depending on how things are configured. So I think again, John's not here. I guess it'd be useful to hear from like David and Martin and other people who are implementers, whether like they find the certificate like richness that helpful, or whether this just seems appropriate.
You have my input in chat. This is a pain in the ass certificates. It's really hard to get the right alert under the different conditions. So I'd be very happy to say just a single thing. Not that people, not that guys have that richness to go either. So that's fine. I guess they can expire. They can't really be revoked in the same way. This is all internals. So
yeah, I think this was largely intended for external PSKs, but again, it just seems like this is like I can't make a connection, right?
Yeah.
Okay, I will take this on board. Thank you. Okay. This brings us to issue 1227, raised by David Benjamin. It turns out that like there are multiple hashes in play when you're doing PSKs. One is the one associated with the PSK, and the other is the one that is associated with the transcript. And at least one case is potentially different, which is supposing you have two PSKs. Obviously, you have to use the hash associated with PSK for the binder in the client hello one because you have no other information. But they might have different hashes associated with them. If you're going to use the one it's just the PSK hash for the binder associated with the PSK and CH1, you obviously should use it for CH2 because that was like part of the whole point of having the hashes associated with the PSKs. So it's clearly you have to do that. But then we have but on the other hand, for the transcript, at the very end of the day, you clearly have to use the negotiated hash. And what hash is used for the message hash reinjection becomes the question. And when David and I talked about this a little bit, it became clear that David thought that that this text said that that you should use the PSK hash for reinjection, and I thought you should use the negotiated hash. And David and I believe, agree that it should be the negotiated hash, but it's not clear what the text currently says. It won't work. It pretty much doesn't work properly if you use the PSK hash. So the proposal is to and so I think in David's model where it said use the PSK hash, he had a hack to make sure that happened, make sure that they matched. I think the proposal here is just to modify the document to make it clear at every point first of all, to make clear that is the negotiated hash. Yes, it does include negotiated Zephyr Suite. So the proposal is to modify a document to make clear that's the case, and in fact, every place we use hash to indicate which hash it is properly in some way or another. So the transcript is clear. So I think everywhere else it actually is relatively clear, but I suppose when I produce the PR, people can object to that. If I concretize it in some way that I think is wrong, that'll be helpful. Okay, so that's what I intend to do. Okay. David Benjamin has also raised a couple of points, 1223 and 1224 about the HRR. And so his point is the general model is kind of confusing. So we don't really say, I think Martin and I had largely assumed that almost every important decision was made in CH2, and sometimes they had to make some preliminary decisions in CH1, but that they were just effectively confirmed by CH2. I think David had sort of assumed that you mostly made decisions in CH1, and then like you just try to pick things out of CH2 and memorize them and try to pick decisions in CH2. And neither is possible purely because sometimes you make decisions in CH1 which impact CH2. So the example David gave in this comment was, imagine what happens if someone offers you like PSK only resumption with no DHE. And so depending on whether you accept that or not, and they also offer you a set of diffie Hellman groups where you need to do an HRR. And so depending whether you accept resumption or not, you might need to do an HRR or not. So this is like a bit of a rat hole, I fear. And so I think and as I understand it from talking to David yesterday for a while, most of the ambiguity comes into play when we're doing ECH. So he's less worried about it now. And so I guess my question would be, what's the minimum thing we can do here to like reduce the ambiguity of this? And what do we not have to do? And so I think we should do the minimum thing. I don't really have a proposal of that. I was actually hoping David could make suggestions or MT, because I think they're a little closer to at this point. But I think, like, as I was sort of saying at the beginning, what I don't want to do is spend the next 6 months or a year, trying to clarify this in unhelpful ways, because it's an improvement to get this out. And then if someone wants to make a bigger pass at it, we could potentially do that later. Unless there's like things that are actively causing people confusion right now. Oh, it's unfortunate. I see Dave Ben's not actually here. Well, I think, Stephen, I don't think ditching HRR is in scope for this effort. So feel free to propose a separate draft, but this is was intended to be like a set of compatible clarification changes. I guess without David Ben being here, does anybody else want to speak up for like substantial changes here? And if not, I think I'm going to ask David to produce a PR, what he thinks the minimum PR is, and then move on. Okay, thank you. Finally, I want to make a last call on some issues. I've commented on these issues. I don't think any changes are needed. I'm just going to go through them very quickly. If anyone wants to object to them now, please do. And if not, I'm just going to close them at the end of basically after this meeting. So in 1206, Ben Kadick, I think going from some comments that have been on the list, suggested that we give more guidance about what should actually be in the cookies. My proposal is not to do anything here. I think it's like, well, I think it's clear enough. I think any more guidance probably risks getting confusing. I'm not going to stop for these. If someone like takes the microphone or whatever, of course, I'll stop, but otherwise we're going to run through them. The second is I had a PR, issue to expand the discussion of recommended, not recommended, and have like another term. But as I understand it, this is being carried in 8447 bis, so this is no longer appropriate for 8446. And so we can just close this. Though we're not closing the topic. We're really deciding we're not going to handle it 8446 because it doesn't belong there. And finally, there was some discussion on more guidance on how to handle multiple identities in post handshake auth. So if the server, for instance, offers multiple identities, or the client does, how do you think about that in your authorization decisions? This, I think we agree, was an application issue, so I prefer to close that as well. Okay, so I'm going to close all these out essentially after I stop speaking. So I believe there were a couple issues that I didn't get to here because I think they're easy to handle, but I propose to handle them and submit PRs for them and try to get a new draft out. And hopefully that's just a working group last call as soon as we get those things done, and potentially David Benjamin's PR. So please consider this your chance to make it, to raise any other issues which I've forgotten. It'll probably take me a couple weeks to a month to like actually do a lot of stuff, but if you but this is your call to raise other issues, and otherwise I'll have to go to 8446 bis. Sean.
No new issues. I think what I heard is the next time you spin a new version, which will come in about a month, maybe the end of April, beginning of May, we will issue a working group last call to get this thing out the door.
That's my hope. I think, given that we already have this protocol shipping, and this is really about clarifying and improving people's lives, I think that like that is best served by actually having the document published. And then if we find that subsequently there's a bunch of other issues, I have no objection to spinning another small bis or twist, or tur, I guess.
Roger. Thank you very much.
Bye-bye.
All right, next I think we have Martin Thompson with SNP. Do you want to run the slides, Martin? Yeah, you do. I think we're not hearing you, Martin.
There we go. Sorry about that. One slide. Nothing has happened really here technically, but a lot has happened in terms of the editorial content of the document. I went through and did a rip and tear and reordered things, rewrote things. I think it's a whole lot more comprehensible than previously. There were some good discussions after that revision that I haven't yet published, but I think it's just removing an appendix was the upshot of most of that discussion. So at this stage, we don't have anyone implementing this. This is probably another one of those documents that it's worth putting in that parked state. I don't know what other people think about that, but I think that's probably the right way to do this. Just sit it in the parked state and see if we can get some implementations going. It's relatively straightforward to do from a client side, so I'd be willing to set up some sort of interoperability event if someone's willing to do the server side work, which I understand is a little more complicated. That's all I have. Questions? Oh, look, someone's getting up to run away.
So, hey, this is John. So I think unless, like, we're not seeing anything else here, I think it pops up on the list. Thank you, Martin, for doing your editorial changes to make it more readable. And we'll leave it parked till we start to hear people beating down the door to implement this.
Yep. Thanks all. I'll give you back your time.
Thanks. Next, we have hybrid key exchange. See, is Douglas on the call? Oh. Uh-oh.
I will note that when we first did this, we weren't sure if he was going to be able to show up at this particular time, so maybe we can just slide this back.
Okay.
If he shows up.
Let me get back here again.
If I may, yeah, can we consider renaming this document now that we have hybrid public key exchange, which is actually now, I believe, an RFC, having hybrid key exchange at least at 2:38 in the morning was extraordinarily confusing to me.
Ecker, I think you're thinking of hybrid public key encryption.
That makes it totally different.
All right, we should move on to the next item, which is ECH update. All right. Who is presenting? Was that Vincent presenting or somebody else? Seems we're having some trouble. Let me see if I can share the slides because it seems like they're not. I don't have access to the slides.
Joe, are you saying they're not available to share via the preload option?
Yeah. Vincent was trying to share and it didn't seem to work. He's failed. And it says a new deck is being shared, but I don't see the deck.
That might have been me trying to press the button.
All right.
Either that or the deck is just blue.
Ta-da!
All right, we
We're
see
seeing it now.
something.
So I can drive. Vincent, you have to share audio as well. The icon that has the microphone button will allow you to unmute yourself. But you could let us know in chat if that is or is not working. Oh, you have a permission problem, I see. Could that be handled with a browser restart?
Yeah, permissions, you'll have to restart your browser.
I think perhaps then in the interest of time, while Vincent sorts that out, maybe we can move on to the next presentation.
Okay. I think the next topic, Sean, do you want to go through the kitten?
Sure. So back in October, I guess there was a message about a draft. It's a draft in the kitten working group where they're including an updates header in top of the. Oh, is that Vincent there?
I think.
Yes.
Can you hear me?
Let's yield the floor and get you onto your draft.
Okay, thank. Can someone share the? Okay, perfect.
Okay, yeah, sorry about that. Just let me know when you would like me to advance, and I will advance for you.
Okay, thank you. So I'm going to talk about the ECH updates and in particular our privacy goal analysis. So it's a
Vincent, we're having a little trouble hearing you. Might need to get closer to the mic.
Yeah, is it better now?
That's better.
Okay, so it's a joint work with Chris and Kartik. Next slide, please. So the basic deployment scenario that we consider is typically a client that wants to connect to a website that is hosted on a client-facing server. So here the backend server is the websites. And so next slide, please. And so for TLS, as TLS contains, can you switch to the next slide, Chris? Okay, so as TLS contains, if I'm supposed to secure communication between the client and the server, it acts first as a negotiation and a DFML key exchange. So we consider also the server authentication with the certificates, and then after that we also model the encryption of the data through the application traffic, encrypted with application traffic key where the key is derived from the full transcript. So all is kind of a recall, but I'm guessing all of you knows about all this information. So in terms of next slide, please. In terms of feature that we looked at, can you switch the slides, Chris? Yeah, so we consider most of the feature that is in the RFC of TLS. In particular, we wanted to model the hello retry request that comes from negotiation, the certificate-based authentication, as well as the pre-shared key and the ticket resumption that are generated at the end of the session. At the end of the handshake, plus any other extension. In particular, we looked at the SNI that contains the identity of the server. So in terms of verification, what's important is that because all those features can be used or not used depending on the scenario that you consider, we need to verify TLS with as many scenarios as possible depending on the feature that you use. Next slide, please. So in terms of security, TLS is supposed to achieve quite a lot of security guarantees. So we have kind of the classical one, which are the authentication and the confidentiality security goal. So in particular, the one that have already been studied in the literature are all of those. So typically key secrecy, the secrecy of the data that are sent at 0 entity and 1 entity. So for 1 entity, even the forward secrecy. And in terms of authentication, you have the client and server authentication, as well as the downgrade resilience to ensure that the attacker is not able to force the client and the server to use an old version of TLS. Next slide, please. So in terms of verification, because you have to consider all those properties and as well as many scenarios, it's important to be able to verify the security goal not by hand, but using automated verification. There have been already many work on this in the past. So here I just mentioned tools that have been used, so CryptoVerif, FStar, Tamarind, ProVerif. But as you can see, the picture is not really homogeneous yet because some work have been focusing on some properties and some others. So we don't have a full homogeneous picture. Next slide, please. But more problematic is that the model do not cover all the features of, I mean, the union of the model usually cover most of the feature, but the intersection, they're not, the intersection of the model is not complete. So the goal of our work was try to have a model that's a model that covers all the features as well as all the security properties. Next slides. So in terms of privacy goal that have been much less studied in the past, so we looked at identity of the participants, in particular the client and the server. We also looked at the unlinkability of the client through several handshakes, and also the privacy of the extension, both on the client and the server side. Next slide. So here the problem is that even though TLS, the current TLS is supposed to guarantee at least the identity, the privacy of the client, unlinkability, and the server extension, there have not been any automated proof fights. So there have been some proof by hand, pen and paper. And of course, for the client extension and the server identity, it's not guaranteed by TLS almost by design because everything is sent in a clear in the client alone. So the ECH extension is supposed to guarantee, next slide, please. The ECH extension is supposed to guarantee all of these privacy goals. Next. So the basic idea of ECH was to somehow encrypt the sensitive information that is supposed to go to the backend with a public key of the client-facing server, with the idea that only the client-facing server will be able to decrypt and forward it to the backend. Okay, but if you just do this, it's not easy still to obtain a privacy guarantee of the identity of the backend server. Next. Because if you just do this simple intuition of encrypted the SNI and even bind it with the client random, you have a very simple attack where the attacker just take the client hello message from the clients, remove the key share of the clients and put his own key share, and then just let the handshake run, and when he receives the certificates of the server, is able to get the identity of it. Okay. Next. So the idea of the ECH that through the many drafts have been to in fact encrypt the whole client hello that is destined for the backend server, which is called the inner client hello, and bind it with the parameter of the client hello that is destined for the client-facing server. So the overall is, if you look at the RFCs, it's called the outer client hello. But even if you do this, you have some issues with some features, in particular the hello retry requests. Next, please. Because even though you have this binding between the inner and the outer client hello, the attacker can forward the first client hello, and upon receiving hello retry request from the server, it can re-inject his own inner client hello, so the third message on the slide. And for the identity of the server, it puts his guess, whether it typically put S prime, which is a guess on the identity of S. So if S is equal to S prime, meaning that if he guessed correctly, then the handshake will continue normally. And otherwise, if S is different from price, or if he guessed wrong, then the server will raise an error, meaning that the attacker will be able to understand whether or not his guess is correct. Next, please. So the key idea here to solve this problem was to ensure that the encryption of the second inner client hello should be linked with the first one, okay, which leads us to the current version of ECH. So next, where we use HPK encryption for encrypting the client hello. So this the setup of the HPK create a context that is updated every time there is an encryption, and same thing that is updated every time you try to decrypt. And so the important part here is on the left that we reuse the context that have been updated and the same context that have been updated to encrypt the first and the second inner client hello, which guarantees you that you have this link between the inner and the outer. So in red is the part that have been modified for ECH, and in black is like the vanilla part of TLS. Okay, next, please. So in terms of verification, we considered the symbolic models, so typically otherwise known as Dolevio model. So where the attacker can have a control over the network, he can read, write, and intercept messages, but it's a bit idealized in the sense that it cannot break the cryptography, nor use side channel. The good thing about using the Dolevio model is that you have very powerful state-of-the-art tool, and in particular, we are using ProVerif. Next. So we only focus in our model on TLS 1.3, so no version negotiation to previous version of TLS. But we, as I mentioned before, we modeled all the features that I've presented, as well as all the security property, authentication, confidentiality, privacy goals, all of them. And ideally, we would have liked to be able to prove all the property with all the feature, but it's too taxing in terms of ProVerif. We put a timeout of 48 hours, as well as a limit of memory of 100 gigabytes. And for some security properties and some scenarios, we were blowing up the memory very quickly. So what we did, next, please. What we did is that we parameterized our model with a configuration file. So we have one model, but this configuration file allows you to easily activate or deactivate features, as well as which key are going to be compromised and the behavior of the client and the server. And just using this configuration file, it allows us to run about 600 run of ProVerif, corresponding to about 20 to 30 scenario per security properties. So our results, next. So we first look at the classical security property. In particular, we rechecked all the property on TLS alone, vanilla TLS, with all the feature activated. So that was almost as a sanity checked, but still now we have a homogeneous picture. And we try to reprove, of course, all of them also with ECH to ensure that ECH doesn't break any of those guarantees. But in that case, because of the blow up in memory, most of the time, we had to deactivate some of the features. So we tried here to present just the interesting scenarios. Next. So in symbolic models, the way we model the privacy of the server identity, so it's going to be similar for unlinkability, client privacy, and so on. But just here, I'm only focusing on the privacy of the server. It's typically it's an equivalence between two situations where on one side you're going to have a handshake with backend server 1, and on the other side a backend server 2. And those identities are known to the attacker, and you put that in parallel with other handshake with other client, other front servers. So you have unbounded number of sessions and everything. And so if the attacker is not able to distinguish a situation, we consider that the identity of the backend server that is used in these two different scenarios remain private. So we did have to consider some fairly standard assumption, simple assumption, otherwise it would break directly the privacy, like the fact that the privacy of the HPK private key of the client-facing server should remain uncompromised, otherwise the attacker can just decrypt the inner to obtain the identity of the backend server. And same thing, similar assumption for the whether or not the backend server have pre-shared key shared with the client, or if they have a long-term certificates. So all of those are it's not very restricting assumption. Next, please. So in terms of results for the privacy goal, so equivalence in ProVerif is even more taxing in terms of memory, and more specifically in memory. It's more taxing in time, but much more so in terms of memory. So we have by default to deactivate the 1 RTT and 0 RTT for the proofs, and so we managed to prove most of the security properties that we were looking at for vanilla TLS, for the one that are possible to achieve with almost the feature activated. And for ECH, we had to unfortunately deactivate many of the features to try to have interesting scenario and obtain the proof. And so currently we are mostly working on improving ProVerif to remove this problem of to reduce this memory consumption, because with the hope that if we manage to solve this problem, we can remove all the cross and put checks everywhere. Thanks.
Can I ask a clarifying question? Hi, Vincent.
Yeah.
Oh, perfect. I didn't realize you're getting to questions. So first, let me say this is like amazing work. So thank you so much for doing and presenting it. Can you? It's really great to have this done. Can you clarify what you mean when you say that 1 RTT and 0 RTT are both disabled? I understand what it means to have 0 RTT disabled, but if you have 1 RTT disabled, does that mean we don't have TLS? So can you tell me a little more about what that means?
Yeah, so it's in the term of the proof. So typically, it means that in the model when you do the proof, normally in the model you're gonna send the messages that are sent at the end, encrypted with the application data. But then for the proof, we assume that there are. We hope that those. Adding those RTT at the end, those 1 RTT at the end, will not impact the proof, because we managed to have some of them when almost remove all the feature and just put 1 RTT. It didn't change anything. But in terms of verification, it really made ProVerif blow up. Like,
right.
I used a server of 500 gigabytes, and in one scenario I was going over that. So here the problem that we really reached the limit of the material, so it's really problematic.
So this means you only go as far as CFIN, but you don't go as far as saying the application data. Is that what that one?
Yeah, exactly.
Okay,
that is correct.
But that seems like totally reasonable. Thank you.
Right. Hello. Yeah.
Yep.
Arnaud Tadei from Broadcom. So it's 2 years I could not come to IETF. So I'm rediscovering a little bit what's going on here. I have a question. In one of your earlier slides, you are saying that you have tested a number of scenarios.
Mm-hmm.
I appreciate the amount of work, and I appreciate the approach you are taking, but let's imagine we consider an enterprise scenario, right? You have ECH in an enterprise scenario. Now you have a customer that has to deal with network inspection. So if you were to have to do this exercise with a more complex environment, where you have people who have to do data loss prevention because they are concerned by compliancy, they are concerned by GDPR, they are concerned by mass exfiltration, they are concerned by attacks, they're concerned by all sorts of other things. Is this something you could extend to a more complex case?
I'm not sure. So you want to add in the model? Yeah, I'm not sure exactly in terms of.
Yeah, my question is, if you were to put your construction into a real case enterprise scenario, where you have proxies, firewalls, load balancing, all sorts of other things.
Uh-huh.
What would
So
happen?
your question is whether or not we would be able to model such a thing?
Huh?
But I mean, yeah, to be completely honest, I cannot give you a definitive answer because it will depend what your aim, well, not what the aim, but what exactly, which feature would need to appear in the model. But theoretically, yes, we could model it and extend the model to have those feature added. I don't know how it would impact in terms of verification, but theoretically, yes, you could add this in the model.
Okay. You are based in France, right?
Correct.
Okay. We'll contact you offline. Thank you.
Thank you.
Yeah, go ahead, Hannes.
Okay. Hi, this is Hannes. Thanks for doing the work. I was wondering whether you have published the paper and released the scripts that you had shown. Would be interesting to verify some of that work. Is that available somewhere already, or?
Yes, so there's a GitHub, a public GitHub that is available online. In fact, it's public, and it's the work is going to be it's ongoing submission to CCS this year.
Okay. So if I send Chris or you an email, I might get access to it.
Yes. Yes, okay. Correctly.
Awesome. Thank you.
Stephen Farrell, just noting that I think I just formed the first actual mic line until Johannes. There was actually a line here. No, but there was a physical line of two people. Hi. So again, thanks for this work. Can you go back 2 slides? The assumptions.
Chris?
There you are. Yeah. Again, I asked this in the chat, but I just wanted to kind of raise it. So I think there's also an assumption here that the same ECH configuration is in use for both BS1 and BS2.
Yes, yes, of course. You have to use. Wait, sorry. For between P.
So the same ECH public or HPK public key is used. Yeah. So
no, not necessarily. I mean, typically, if the client-facing server has several configuration possible, so of course, is public key. Wait. No, yeah, sorry, my bad. It has to have the same public key, yes.
Right. So given that those are read from the DNS entries of the backend servers, they could differ because of caching in DNS or something, and even you might even have different groups or something. So it would be nice to try and write down the assumptions there, so that people have some guidance as to what not to do in terms of publishing ECH configs in DNS.
Yeah, indeed, I agree.
Thanks.
I'm not completely in terms of implementation detail. I'm not completely aware of the how the link with the public key of the frontend server with respect to backend server. So this, I think, Chris would be able to answer those questions more in detail.
Yeah, I mean, so I think in terms of the analysis, hopefully it shouldn't make much difference as long as you use the same group. But it'd be nice just to have that written down somewhere that as guidance for people publishing DNS records.
Okay.
Jonathan Hoyland, Cloudflare. I just want to say this is super awesome work. I think it's so exciting. How does ProVerif handle using 500 gig of RAM? Does it just choke, or does it work?
Well, it does work. I mean, the thing is that the ProVerif typically has to store it, translate your process into own clauses. It has to store like a huge amount of own clauses. So the storage in the end, it's just a normal. Doesn't really make any problem with ProVerif. It doesn't have time to go through the memory, but it's mostly your limitation of your server. So from the ProVerif point of view, it doesn't have any problem handling 500 gigabytes if you have 500 gigabytes available, of course.
It doesn't get bogged down in syscalls or bus width? Or
I mean, from my experience, I mean, when it's the first time that I had to handle that much memory for a model. So I'm not gonna say definitively that it's not a problem. But apparently the only error we got was every time where we would reach the limit of the memory, and then the call would just be erased by the system, and that's it.
Very cool. Thank you so much.
Okay, thanks, Vincent. I think we're getting ready for the next presentation. All right, Douglas.
Okay, good morning. Can you hear me?
Yeah.
Great. So I'm here to give a quick update on hybrid key exchange. And I guess I saw in the chat there is a discussion of the word hybrid. Hybrid in this setting is meant to refer to the use of multiple algorithms together. So the motivation of this draft, and I've presented this before, is to permit the simultaneous use of traditional and post-quantum key exchange in TLS 1.3. And that thereby enable early adopters to get post-quantum security without discarding the existing security that might be offered by current algorithms. And that would reduce the risk of the break from one algorithm and help maintain standards compliance during the transition to post-quantum cryptography. So in this document, the goals are to define the mechanisms for negotiating and establishing a shared secret using hybrid key exchange. But there are several non-goals. So it is not a goal to select which post-quantum algorithms are actually used in TLS. That's the ongoing work of Nist as well as CFRG. And it's not a goal to do hybrid or composite certificates or to do digital signatures. Some of that is being done by the LAMPS working group, and others will have to be done later by this working group. So the mechanism in this document is to just define a new key exchange mechanism, a new key exchange group for each desired combination of traditional and post-quantum algorithm parameter sets. And that will act as a new opaque key exchange group. And then from that main idea, negotiation is straightforward using new named groups for each combination, which will have to be standardized subsequently. Key shares are conveyed by concatenating the key shares for each algorithm and setting them just in the current key share fields. And then shared secret calculation is done by concatenating shared secrets just as byte strings and then inputting that into the key schedule. And I note here that concatenation is a combiner for key material that's been approved by Nist as maintaining FIPS compliance if one of the keying material inputs is FIPS compliant. So that's the main mechanism, which I've presented before and has not changed since previous discussions. The main thing since I last presented was a discussion on the mailing list started in August 2021 by Nimrod Avaram and his colleagues about whether concatenation is in fact safe to use. And they started from the premise that if the hash function used in the combiner is not collision resistant, then it may be possible to learn some keying material. And the conditions of their scenario were actually that the hash function needed to not be collision resistant, and that collisions could be found within the lifetime of the TLS session. That the first byte string in the keying material is variable length, and that the ephemeral keys used in the second component are reused for a long period of time. And this is based on similar to the crime attack. It kind of works in a byte by byte scenario. So this was very interesting and obviously has some significant assumptions here, and asking for security in a world where the hash function is not collision resistant is a challenge, and there are certainly impacts on other parts of the TLS protocol as well. For this specific attack, it ends up not applying. While the first and third conditions could plausibly hold, the second condition, that the first keying material component is variable length, is not satisfied. So in all standardized TLS 1.3 Diffie-Hellman groups, the shared secret component is fixed length. And so it is not possible for this attack to apply to the draft as stated. So at this point, we decided that that meant we did not need to make any changes to the draft. Now, this is still a worthwhile exercise, given long-lived, hard-to-upgrade implementations. How should we design our protocols to be robust against algorithm failure? And it may be worthwhile for the TLS working group to further consider the role of collision resistance in the protocol design of TLS 1.3 overall. But at this point, we don't see a need to continue the adjustments to the hybrid key exchange draft as a result of this document. So where we stand now is that we don't have any known pending tasks for this draft. There are several interoperable implementations at this point here, some from the Open Quantum Safe projects OpenSSL and Boring SSL forks, as well as Wolf SSL and Amazon's signal-to-noise library. The specific PQ algorithms to be used in this context, as I mentioned, are going to be identified outside of this document when the Nist round 3 process concludes, leading to CFRG, and then finally to TLS. So I'm not an IETF procedure expert, but I think it may be the case that this could move to working group last call. So I'd like some guidance on how to proceed here, and of course, happy to answer any questions that come up.
Okay, Martin.
Yeah, thanks for this, Douglas. When you, on the previous slide, I think it was when you said that we're not making any changes in the document. Have we stated our assumptions very clearly? Okay.
There are statements in the document that, sorry, I guess when I say no changes made to this draft, there are no technical changes to made this draft. We did mention this scenario, and there is a clear statement that this document is only meant to be used with algorithms that have fixed length shared secrets, to be clear that we require assumption B to not be satisfied.
Perfect, thanks.
Stephen?
Hi, Stephen. Just on the question of working group last call, I mean, generally, I think a lot of this work is being done too soon, all this post-quantum stuff. I might be in the minority there, that's fine. It would seem very weird to have a working group last call on a protocol document where the algorithms that are used are unknown. So if we have, if we're starting a practice of parking documents until people implement them, maybe we should also park documents until the actual cryptographic algorithm details are understood.
So I take your point. And I guess my goal had been to make sure this mechanism was ready when people wanted to use it. And really, I'll defer to how the working group wants to proceed in terms of process, because I'm not an expert on that.
And I think we could have a working group last call and not move the document forward after that, depending on, to kind of get feedback on the current state.
So again, yeah, this is more a question to the chairs, I guess, for sure. Yeah. I mean, so I just don't understand how you could consider something being a last call when the underlying cryptographic algorithms to be used are unknown. We don't know which ones Nist will pick or not pick, for sure. So.
All right, hey, this is Sean. Just to use chair prerogative to jump in here. The only thing that I would add to the last bullet there is, could we move to a working group last call? It doesn't have to be the working group last call. The problem is that I think that a lot of times that people don't really review drafts unless we start to say working group last call. And I think Doug's only point is, hey, we want people to look at this so that when the our algorithms are actually announced, that they can move quicker to implementation. I don't want to mischaracterize you, Doug. Is that basically what you're thinking?
Yes, thank you.
Okay, so then I guess I'd ask the chairs if you could kind of be specific about that we don't want an RFC popping out before we know what the actual result of the Nist competition is, I think, right?
Oh yeah, absolutely. So that was when we first started this whole draft. That was the, we're not going to finish this until the algorithms get picked. So that's supposed to happen any moment now, possibly, today. Who knows? Maybe it's SAG tomorrow. Who knows? But so the algorithm is supposed to be coming fairly quickly, and so I think it's just trying to get this draft in the right place to launch forward. So sorry for using chair prerogative there to jump in the queue.
No, and thanks, Sean. I mean, it really was a question for the chairs and not so much for Doug.
Becker?
Yeah, working with bus call seems appropriate to me here. I have no problem with parking it until the algorithms are announced. As far as I can tell, no significant part of like no significant part of one's review of this document actually depends on what the algorithms are, because it's intentionally algorithm agnostic. So if we assume the algorithms are sound, then then it should not matter to me which algorithm it actually is, which is fortunate, as I don't understand the algorithms. Could you go back to your to the slide about the active attack, please? Right. So I think your proposed resolution is fine, but I just want to push. So let me just say that in advance before I push. Suppose we were to introduce a TLS 1.4 or an extension which had a more collision resistant, a more length ambiguous resistance structure, right? Would that and the client and the server are both upgraded to that mode, and so they would negotiate it if left alone, right? But of course the attacker can do whatever they want, and the client and server also have to jointly do the older mode. So in the wild we have like the structure we have now, and then some future collision resistant structure, and we have negotiated that, and both client and server have to switch it between them. Is this attack going to still be possible, or will the fact that the client and server will naively negotiate the stronger version prevent against this attack?
So you're imagining a scenario where there's this version which is only used with fixed length elements, and then there is a version that can be used with variable length shared secrets, but has some protection mechanism, padding, or a different combiner that is meant to protect when using variable length secrets?
That's a good question. I was imagining that we stupidly relaxed the restriction on it being fixed length secrets. And you use this version. So I was imagining. So I think I hear. Let me see if I can recap what I hear you saying, which is this is entirely safe because we're requiring fixed length secrets. So I think what I had in mind was, imagine we actually foolishly allowed it with variable length secrets. But I think the question that you're phrasing still is a reasonable question, because we still have the possibility of the two versions you described jointly existing.
Right. Okay. So if there are two modes of operation, both of which are secure, so where in the variable length setting there is appropriate protection, and in the other setting it is ensured to use fixed length, my intuition tells me that would be safe, that there wouldn't be a downgrade route. If one of them is weak, for example, one did allow the one on the screen here to be used with variable length secrets, I believe it would be possible for an attacker to attempt to downgrade to that, including rewriting the transcript history to make it appear that one party, for example, did not support this more secure option, and therefore this one had to be negotiated.
And does the signature of the transcript help, or is the attack already in place before the signature is validated? Sorry, this is a pretty detailed question for this early in the morning.
Yeah, I'm not sure off the top of my head how the signature validation ties into that. I think, well, if the hash function is not collision resistant, the signature is over a hash of the transcript. So you could have attempted to rewrite the hash before it was signed.
Yeah, maybe. Right, that would be potentially be a pre-image, I guess. So okay, sorry, this is now a not very interesting question. So I think the relevant point, as I take home, is that if we ever were to specify if we were in the future to attempt to specify a version of this that had sorry, if we were to specify a variant of this that, as you say, potentially through padding or whatever, was length dealt with variable length correctly, as opposed to making the algorithms. If we have variable length algorithms, and we have two ways of doing that. One is to make the algorithms fixed length under the hood, and the other is to have a version of this that deals with variable length algorithms. And if we were to do the latter, then we have to have a filter in the negotiation system that said if that you can't do hybrid key exchange with variable length algorithm blah unless you also have the new combiners in place. So that suggests that we're really committing. So that suggests that, as a practical matter, we're probably really committing to having fixed length algorithms later, because that filter's annoying. But I mean, we could if we had to. But that kind of pushes us down this. I think it's probably the right answer. But I just try to think through it.
Correct. I think so, Eric.
Okay, great. I think this is great. Sorry, I didn't mean to take us too far down the rabbit hole. This is great, and I think we should go over the work that last call.
Thanks. Yeah, I will mention that Aviram and his colleagues did propose a combiner that does work with variable lengths using some more extensive hashing construction. So it is possible to do that at this moment. And if the working group prefers to do that, we can. But we chose to not do this and focus on fixed length instead.
Thank you.
Shall I go ahead?
Yep, go ahead.
Yeah, so hi, I'm Nimrod. I'm one of the people that sent this email. I think one perspective we can use is there an actionable attack under reasonable assumptions? And some of the assumptions are pretty hard to meet. Another perspective we could take is, can we prove the security of this? And my understanding of the literature around key combiners is it will be very hard to prove the security of this whole protocol absent assumptions like the whole hash function is like a random oracle. So I get that people are not worried about this attack, and this is fine by me. I would note that we are kind of baking in something that will be hard to prove later. So I think we might consider how do we expect to upgrade the key combiner function if we ever choose to. Alternatively, if we're saying we don't plan to ever ever use a different key combiner throughout TLS 1.3, then we should probably be explicit about it.
Okay. Yeah, thanks, Nimrod. I mean, we've talked about this before, so I don't know that I have anything to add, but
yeah.
If there are any other questions.
I think we'll move to the next, Nicholas.
Yeah, hi, Nick Chakowski, NSA. Yeah, I just wanted to make a comment just to follow up on the working group last call. So like the document is it's not very specific on reuse of keys, ephemeral keys. And that is an issue, and it does note that is an issue with some of the lattice-based mechanisms. And because of well, it's common with the lattice-based protocols, and I guess part of the reason why it's kind of a little loose on the guidance, I suspect, is because we don't actually have the specification written and how certain things would be done with like key encapsulation and it just Nist, the competition's about done. They have their candidates they have in mind and stuff, but the details aren't set, and they're not going to be set until Nist writes the standard. That'll take a little time, and so so I just want to stress it's a little early because you can't even pin down how to handle reuse of keys without having that other component finalized. So I just, just wanted to put that out there.
Okay, yeah, so the document does not say that ephemeral key reuse is prohibited, because TLS 1.3, in fact, if my understanding is correct, does not prohibit ephemeral key reuse. It does permit ephemeral key reuse, which is viable under the CCA security definition for chems. The document does clearly state that the reuse of randomness in chem ciphertext generation is prohibited, which is also kind of compatible with the CCA2 security definition in the Nist competition.
Okay, Nimrod, did you have a final comment, or are you next in the queue? You're next in the queue. Okay. All right. Thank you, Douglas.
Thank you.
Your slide should be up shortly. Okay, we can see the slides here.
All right, and everyone can hear me, right?
Yes.
All right. So hi, everyone. My name is Nimrod Aviram. My co-author, Kerik Bartel, is also here virtually, and we would like to deprecate obsolete key exchange methods in TLS. What this document does is it deprecates RSA key exchange and static finite field Diffie-Hellman, limits finite field Diffie-Hellman in its ephemeral form to only reasonable groups with sufficient security, and it discourages static elliptic curve Diffie-Hellman. For those keeping score at home, this version came out of merging two separate documents that were presented at previous meetings. As we've argued in those previous meetings, this would be fully practical. For the web, it's consistent with Mozilla's server-side TLS guide and would be compatible with almost every web client release since around 2015. For email, the picture is more complicated. However, we would note that email encryption is largely opportunistic anyway. And previous discussions in this working group seem to conclude that we should move forward with this, as the alternative would be to allow problems with other ecosystems to affect the web. The approach of letting other market segments be does not isolate the web from potential security harms. For example, consider Drown, a Bleichenbacher attack from 2016. 17% of web servers were affected because they were directly vulnerable, and an additional 16% of web servers were affected because they shared an RSA key with a different vulnerable service on another host or port, and these were mostly email ports. These types of attacks, like Bleichenbacher type attacks, allow RSA signature forgery, and the forged signature can then be used for a man-in-the-middle attack against web clients and hosts, even if they don't support RSA at all. So even fully deprecating RSA key exchange from the entire web in and of itself would not isolate the web from problems with RSA. This is obviously in addition to the usual problems with RSA, namely there's no forward secrecy and the risk of a direct form of Bleichenbacher's attack, which practically happens every few years, even without key reuse. For finite field Diffie-Hellman, the document merely requires the minimal properties that guarantee security. That is, full ephemerality, appropriate group size, and appropriate group structure. As for static elliptic curve Diffie-Hellman, these cipher suits don't provide forward secrecy, so they are already listed as not recommended. And also, because they reuse secrets, this opens the door for a class of attacks that exploit the secret reuse to gradually learn cryptographic secrets, and we've had quite a few of those over the years. However, we have in the document static ECDH merely as a should not. This version tries to incorporate everyone's useful feedback from previous discussions. Several people have argued that we should deprecate RSA key exchange in parallel to deprecating static FFDH. And we've done so by merging the documents. Some people have argued for full deprecation of FFDH, even when fully ephemeral. And it did not appear to me there's consensus for this. And I would argue this is probably unnecessary. Because the requirements in the document should be enough to provide security. FFDH is not mandatory to implement, and implementations are free to drop support, as most web implementations have already done. And we can make it explicit in the documents that document that the implementations are free to not support FFDH at all. But if someone needs FFDH and can operate it securely, which is kind of equivalent to the requirements in the document, then I would argue we should probably allow it. And as for the last bullet point, we still have a few open questions around FFDH, namely, how would the client verify that the group is safe and what it would do if it can't verify that the group is safe. I think we can sort those out on the mailing list, but if anyone feels otherwise that it should be discussed during this meeting, then please speak up. That's it for me, and I'm happy to take questions. Thanks.
Yoav?
Yeah, Yoav. I'm sorry, Yoav, I don't think we can hear you.
Tells me that you are hearing me. Okay. So there was a conversation on the Jabber room that this looks like an update of RFC 7525. It's recommendations for how to use TLS, which is really more about configuration, because I assume this is all about TLS 1.2 and lower, because 1.3 already deprecated all these things. So Utah wrote this RFC 7525 about how you should configure your TLS 1.2 and lower. And if you want to revise that one, that's also a great idea. But I don't think we should just deprecate the protocols one by one, or the algorithms one by one, rather than put it in this big how to configure a TLS 1.2 document.
Do you imagine a scenario where someone would use RSA KXG, or say static finite field deferment? Do you imagine a scenario where someone uses that?
Sorry, I don't understand the response. I mean, I'm just saying that this sounds like part of what Utah has been doing, rather than something that this working group should work on.
I think that's a valid point. So, like, if we think that an algorithm is broken, do we treat that as the configuration knob that someone would configure, or do we say this is broken?
Well, I'm not going to fix OpenSSL 098 to get TLS 1.2 safer. And people either upgrade to the latest OpenSSL and get 1.3, or they configure their 098 to not have bad stuff. So that it looks to me like the what you're specifying is how to configure rather than changing the protocol.
All right, thank you. David Benjamin, why don't you go ahead?
Hi. So I think, maybe we should also, I don't know if Utah is also a place to do this, but we have had other drafts in this working group to deprecate things that are broken. We recently published 9155, which is like SHA-1 and MD5. I think we also deprecated TLS 10 and 11, and we had RC4 before that. So I think this is at least consistent with what we've done historically. If we want to do something different from historical things, that's fine. But otherwise, I think this draft is perfectly reasonable.
Thanks. Oh, by the way, also, I spoke with someone on the Utah group whose name escapes me, and they said they would want like our working group to first deprecate some algorithms before saying before disrecommending them. Yeah, just saying that. Was there anyone else on the queue?
Your own?
Yeah, yeah.
Yeah, as a course on 7525 and 7525 bis, I think that what you just said misrepresents the consensus of the authors and I believe of the working group. 7525 has deprecated stuff that wasn't necessarily like set in stone by the TLS working group. And I totally agree with Yoav that, yes, in the past we've had duplication of work between the TLS working group and the Utah working group, and it's time to stop it. Thank you.
I'm sorry, could you repeat that last sentence?
In the past, we've had duplication of work between the TLS working group and the Utah working group. And so in some cases, it was warranted. I think it was, in fact, up to the TLS working group to deprecate earlier versions of TLS. But for the smaller stuff, I think it would have been better for everybody, including the customers of these documents, if we had done the work once. And right now, the right forum for that is, in my opinion, the right venue for that is Utah, and specifically 7525 bis.
All right, thank you. I guess we're done with the queue. Do I need to stop sharing my slides?
Let Panos give his. Oh, okay. Panos is next. Okay. Yeah, I think chairs will have to. We can discuss with the Utah chairs and see how to proceed.
All right. Thank you.
Folks, hopefully you can hear me. Let me know if you can.
You're very faint.
Let me try to change my source. How about now? Still faint?
Yeah, I think. Can people in the room hear? Still kind of faint.
Let me restart the browser 1 second. I'm back. Hopefully you folks can hear me now.
Much better.
All right. It was the headset. All right. Hello, everyone. My name is Panos Kampanakis with AWS, and I'm here to talk about a new draft we submitted about a month back with my co-authors, Martin, Bass, and Cameron. So this draft is practically an attempt to revive Martin's old TLS suppression draft from 3 years back, I think. And, it's a draft that tries to address a well-known, well-understood problem. Basically, we all know that TLS is heavy on authentication data. We know that it includes a bunch of signatures and public keys that come down as part of the certificate, the identity certificate and the certificate chain to authenticate the identity. We know that it includes certificate verification signature. If it's for the web, we know it includes 2 or more SCTs, and in some cases it includes an OCSP staple signature. So we know that there are a bunch of signatures and public keys included in these handshakes, and that could introduce issues for some use cases. So basically for the post-quantum use case, all post-quantum signatures that are being considered for standardization by Nist have relatively big public keys and signatures. So, that could lead to 10 or more kilobyte of data increases in TLS for authentication, which could lead to TLS slowdowns. There have been research papers published on this, and Bass published a very good blog post where he tested big certificates and certificate chains, and he proved that if we go over 10K, then we start seeing double-digit slowdowns. So there could be some slowdowns introduced by post-quantum signatures, and also Quick would see and at least one extra round trip because of its amplification protection when we're talking about invalidated, IP addresses that have not been validated yet. So Quick would see extra round trips there because of these public keys and signatures. There are also some other use cases that are discussed in the EMU work group that deal with IETF and big signatures and the issues they could bring in these use cases. So John Matson has these drafts, and he has talked about this before. And finally, I've seen some use cases in mesh networks where there are constrained mediums, and we have certificate chains could cause slowdowns there where the medium is constrained and everyone is fighting over just a little bit of bandwidth. Someone could argue that CTLS tries to address that issue there as well. So that's the premise, that's the idea behind the draft. And the solution that we're proposing, it's using the TLS flags draft in order to signal ICA suppression to the peer. So basically, we require to pre-acquire a fresh ICA list. That's the list of ICAs that someone would use to verify the peer's chain, and we require it for it to be fresh in order to avoid failures, in case that we have entries that are expired and that shouldn't be used, that they're old. So we first use an ICA chain, an ICA list, which we preload, let's say, on the client. And then, the client could signal to the peer using a TLS flag to say, don't send me your intermediate CAs, and that way alleviate the protocol. Why we're proposing this? It's for the post-quantum use case. We know the post-quantum use case would suffer. So, using a mechanism like that would keep the authentication data within a limit that's relatively acceptable based on testing. So it would save 1.5 or 3 kilobytes if we're talking about one ICA. And if we're talking for Nist's leanest 2 signature finalists, if we're talking about other signatures, it's even more. Or it would save 3 kilobytes or 6 kilobytes if we're talking about 2 intermediate CAs for Nist's round 3 Nist post-quantum signatures. So, it helps a little bit the post-quantum use case. It also helps the EMU use cases that I mentioned earlier. We also have to say that we consider this low-hanging fruit. It's a relatively easy mechanism that can be implemented. It doesn't require great redesigns of protocols and stuff. So we wanted to give a little bit of data on the ICAs, or the ICA list. So if we're talking about Web Pki, the total number of intermediate CAs would be around 1,000, or let's say 1,500 intermediate CAs in the list that we would need to keep. And that could amount to 1 or 2 megabytes of compressed data that would have to live on the client or on the verifier, let's say. So these are not, these are manageable numbers. They're not too big numbers for most use cases. And also at this point, I have to mention that if we're talking about the non-Web Pki use case, the ICA list does not even have to be statically preloaded and defined. There are some use cases where we could build the intermediate CA list dynamically. And these are use cases that are not for the web, right? They're use cases where we have a very limited set of peers and a very limited set of ICAs. In the draft, we defined that you can allow the server to send its intermediate CAs if it knows that they're likely to not exist on the client. So that could be a constrained ICA list. So, in that case, the server may choose and say, I'll send it no matter what because I want to prevent failures. Or another use case could be if there was a third party that was hosting these intermediate CAs, then the server could confirm if its ICAs exist there or not. And in order to prevent a failure, it could decide to send them if they don't exist in that ICA list. So, the draft allows for these use cases where even though the client may be asking for it, the server can make the decision to send them to prevent a failure. At this point, I also wanted to bring up that we have some similar precedents that would make the deployment of such a draft relatively easy. So we know that Mozilla Firefox already has an ICA preload list. That list is not used for the same reason. It's used to prevent outages, but it's a list that's loaded on the browser already. We also know that the browsers deploy some sort of list for revocation, whitelists or revocation lists. So there is a mechanism to deploy such lists to a browser. And we also know that the CTLS draft that Eric was presenting earlier also defines compression certificate dictionaries. So, it's also mentioned in another draft. A mechanism like that, So we have a couple of open questions that have not been addressed in the draft, and we want to work on them.
Panos, if I may, we're basically at the end of time,
okay.
and trying to make room for the next presentation.
That's cool. Let me mention the asks, and it should be cool.
Yeah, I imagine there's going to be good questions, so I wanted to make sure there's time for questions, but also time for the following presentation. I'm sorry to just sort of jump in like this.
Yeah, no worries. So thank you. I'll jump the open questions. There are a couple of open questions that we haven't answered, and we're planning to think about them. The last slide I want to bring up is that there could be some challenges for Web Pki, and Ryan has brought them up on the list before. We think that we can address them, but I would also suggest the group to not forget that TLS is used in a bunch of other use cases that could benefit from this. And I would like to ask for a discussion in the list or on the GitHub repo. And we will not ask for workgroup adoption. I think maybe in the next IETF, we first want to think about some of these open questions before we ask for workgroup adoption. And we also want Nist to pick algorithms. So that's what I had. Let me know if there are questions.
David?
So I think you partially mentioned this in the last slide, but I don't think this draft as is will work for the Web Pki for the reasons you mentioned. Like while we do have precedent for pushing lists and stuff, this draft assumes that the list in all the browsers gets like updated basically instantaneously, whereas there's going to be this long tail of like clients that still are on an old list. And so you're basically going to be stuck with the servers always assuming they have to send the intermediates, or like some intermediates just won't work. I could imagine a more complicated scheme where we like name the lists or something, but that would be slightly higher hanging fruit than this low hanging fruit. Maybe for non-web use cases it'd be useful, but it sounded like you were pretty interested in the Web Pki case.
Okay.
Thanks, David.
I think we're going to cut the queue here and ask the rest of the discussion to go to the list so that we have time for our last presentation.
Thank you.
Sorry, folks, but.
Okay, let's try to figure out how this works.
That should come
share,
up in a
and
minute.
then I think Oddcam updates. Very exciting stuff. I can do it from my phone. So we don't have a lot of time. Thanks everyone for being here, of course, and also those that are in unfortunate time zones. I'm just going to give a brief update about the Oddcam draft. So what did we do last time? We introduced it. The idea is basically, instead of doing authentication via a signature, we do it via a key exchange because that is better post-quantum, possibly smaller, more efficient. But we realized that we hadn't had a lot of space in the RFC to do also why. This is a good idea because it's mainly focused on all the implementation stuff, and we had a bunch of questions. So in this presentation, we have basically what do we need from you to make this thing better, a bunch of the small changes that we made, and some bigger changes. And we have this Oddcam abridged sort of behind the scenes document. So let's start with what do we need from you. Basically, we need feedback. It is not a small change. And we would like to know, does this fit for you? Does this not fit for you? Stuff like that. We also need some, I'm a first-time RFC writer. I'm used to writing scientific papers, which is quite different. So yeah, that is quite visible still. And it's been mentioned a few times, the Nist finalists are going to be announced very soon, probably end of the month. And when that time comes, it will probably be very nice if you investigate if they fit in the way that you use TLS. And especially if the signature schemes are problematic, if possibly Oddcam could solve problems for you. Oh dear. Yeah, the changelog. So we restructured the whole thing. We split the protocol diagrams from a lot of implementation details, and we hope that that makes the thing a lot more readable. This is really the most important thing that we changed since revision 00. So you'll find that it now first introduces the arrows on the paper before it starts to go into how do you put those arrows into bytes and then transmit them over the wire. Some other things that we did was we used now HPKE more fully, and we added some certificate request context to the key and caps messages to possibly be able to keep track of those a little bit better. So, Oddcam abridged. This is intended to be more of a sort of living document where we just try to sort of do Q&A and provide intuition. We don't want to sweep anything under the rug here, so we also very much try to clarify all of the open questions and the more tricky security intuition bits. And we really, really would like also help there. So please ask your questions either directly or in the mailing list. and we will also try to keep this document up to date. So some of the things that we have there, for example, why do we use chems for authentication? Stuff like, how much time do we have? 5 minutes. So again, end of the month, we should see announcements from Nist's PQ thing. The signature schemes it's looking like it's going to be either quite big or quite annoying if you have like a small microcontroller that can't do floating point maths. And it's quite probably going to be just one of those two options. So that is why we think Oddcam is worthwhile. Why do we not do draft semi-static is another question that we saw last time. I really like the idea behind the semi-static Diffie-Hellman key exchange. Unfortunately, it doesn't work post-quantum. Why do we want to do it now is also something that came up. And our answer there is that really this work is very hard. And post-quantum, this move is a really good opportunity to re-examine the things that we have right now and to see if that still worked instead of just scribbling in PQ in front of all of the things. The last meeting already identified a rough edge, so we really see that this interaction is helping, and we want to file down all of those rough edges, and that is going to take a lot of effort. And is this finished enough was also something that came up. We have a lot of academic work going on. We are working on a Tamarin proof. Actually, we've mainly finished that work. We've extended the TLS 1.3 model, and Douglas has also done a model of the ChemTLS protocol. And research has a hard time finding out the practical stuff, though. And we think that also this interaction helps in that area. Let's see, next. There we go. Other things to read are like why we added another handshake secret and why we put chems into signature algorithms, because clearly chems aren't signature algorithms, and just small stuff like that. So again, we would like to hear from you if you want to help or have feedback, want to comment on any of the open issues, or want to point out something that we missed. Unanswered questions, really, there are no dumb questions. And also, if you have something that we should investigate, if you want to work with us on some experiment or really do whatever, if you want to say that we're being idiots and forgetting something really stupid, that would also be helpful. So yeah, that is, I think, my ask to the room today. And I think that was my last slide.
Okay, the queue is open for.
Don't be shy. Well, I guess I was very clear. If you come up with something later, our email boxes are always open. So I don't think I'm particularly hard to reach. And also, for those here in person, you can also always come up to me with questions. And if that went very fast for you, I think the slides are on the data tracker. So you can also go at them at your own pace. But yeah, I was asked to hurry up.
Okay. I think that draws TLS at IETF113 to a close. Looking forward to seeing everybody online or in person at the next IETF in Philadelphia. And on the list in the meantime.
Thanks, everybody. Bye-bye.